Okay, again, ignore the mess behind me. I am going to make a video here for class relationships. Also, my neighbor is mowing the lawn, so hopefully that won't add too much interference. Last time, so I'm going to go to the screen. Last time we talked about abstraction and encapsulation, talked about how you define a class. This is about how classes relate, and it adds the other two elements of object-oriented theory, inheritance and polymorphism. Inheritance is where one class inherits from another, and it always moves from the general to the specific. For instance, you could go from a user to an instructor. An instructor is more specific than user. You could also do like user to administrator, because an administrator is a specific kind of user, which is the other thing. For inheritance, they have to be, the inheriting class has to be of the same kind as the parent. You can't inherit, for instance, an instructor is a kind of user. An administrator is a kind of user. A door is not a kind of user, right? Or a database is not a kind of user. They have to be of the same kind of thing. So inheritance can be really useful for saving code, so you don't have to write the same thing over and over again. One of the goals and one of the rules of object-oriented programming is you should never write the same thing in two different places. It should always have one place to live and nowhere else. Polymorphism means that things change depending on the context. There's two ways to do it. You can override a method or you can overload a method. Python doesn't really do overloading, but it does override things. One of the most common things it can override is the string method, so that it can return a different thing depending on what class it is. It's always named string, but it always returns different things depending on the context. We'll see that more when we do some coding. So, among classes, there are 4 types of relationships. Association is one of the most common. It just means that one class calls a method in another class. They just talk to each other. So association is very common, and it doesn't involve anything special. It's just one class calling a method in another. Inheritance is where one class inherits all the public attributes and methods of a parent class. Again, it saves on code reuse. I'll show you the symbols for these in a moment, and we'll talk a little bit more about it. Aggregation is where a class contains another class within it, usually as a variable. But the contained class has its own existence, so that if you were to destroy the container class, the one inside of it still has an existence all its own. It's not dependent on its existence on that outer class. Composition is the same thing, except that the inner class is destroyed when the container class is destroyed. I realize that probably isn't super clear, but again, there are some Google Slides and other things to look at about this. So let's look at a couple of examples. This is like a card and a scan. So this is just in a relation. So the scanner gets the integer from the card. I'm actually not sure that's how I would do it, but I just wanted an example of an association. An association has just a line. Sometimes you can put sometimes it has an arrow, a little simple arrow, but generally it's just a relationship between these two classes. It's just a line. Inheritance has an open triangle as at the end, and the triangle always points to the parents. So every person has a name and an address and an email. And then I put the gets down here so that you could see that, you could get those classes. So in a customer, I don't have to type name, address, or email because it inherits that from the person class. It also inherits each of these methods. What a customer has that's unique to a customer is a customer number and some rewards. And then I added a couple of methods to add rewards and subtract rewards. An employee, again, is a type of person, and it'll have a name, address, and email. And the employee also has a position and a hire date. And they might have some methods too. This is just to show the relationship. So this is inheritance. Inheritance has an open triangle pointing to the parents. And each of these is a type of person. They're just a more specific type of person. Association, they just talk to each other. Inheritance is a more direct relationship where you can, and there could be further, inheritance could go down further. There could be different kinds of customers. There could be different kinds of employees. I mean, so I can devolve, and each, if I were to do another one, let's say another type of employee is part-time employee. Let's add a couple of employees. So I'm going to find my class diagram. Where is the basic class diagram? There it is. So I'm going to do another class here, and I'm just going to say that there is a type of employee that is salaried. And I'm going to just delete that. Well, maybe delete it. So they're going to have a salary, and maybe they'll have some other stuff too. Like, you know, calculate annual salary, calculate monthly pay or something. Whatever. So when I do this, it comes there. I'm going to click on that. I'm going to come up here, and I'm going to do that. So basically, when you have something like this, so we have a chain of inheritance. We have person, so the email address, name, email, and address get transferred to here. They also get transferred to there. Every child inherits everything from every parent, however far, parent and grandparent, all the way up down the line. So salary will have name, address, and email. It'll also have employee number, position, and hire date. Okay, and then it also, in addition, has a salary. So that's inheritance. And it can, as I said, be quite useful. There's some theorists that think it's a bit overused, but that's up to that. So I've got a couple of other things, and these don't necessarily relate to the topic at hand, but this is the symbol for aggregation. So a section in a classroom is a list of students, right? So I have students and the type is list. I have one instructor, I have the classroom, I have the meeting times, I have the quarter. We have add student, remove student from the section. A student is its own object, and there's a list of them in the section, but a student has an existence separate from any particular classroom section. And that's why this is a empty triangle. That means aggregation. Let me get a text box. And I'm going to just real quickly write why does it not want to do this? Let's just do text. Aggregation. Okay, and this is composition. So I'm going to put that underneath it. So composition is where this is the containing item. It has a list of menu items, and then the menu item is part of that list. If the menu is destroyed, I'm going to say that the menu item is destroyed. That's what this means. That the menu item is wholly contained in the menu and doesn't have an existence outside of the menu. That's really just a subtle difference, and I'm not going to be too strict about that, because sometimes it's a matter of judgment as opposed to an absolute fact. Does the item have an existence separate from the section? Does a menu item have an existence separate from the menu? Does a student, I think it's fairly obvious, does have an existence outside of this section. And this one, I think you could argue that it's part of the menu, and if the menu's gone, so is it. Does that make sense? It's a matter of contain. Notice the students list. This is a student. The list of students is a list of student objects. The menu items list is a list of menu items. These are both very powerful ways of making classes relate to each other. All right, one last thing. It's actually here. All right, so this is a bigger picture of the whole thing going together. So a user relates to the lock. Basically, they pass in their location ID, their user ID. Don't see it here, but it should be there. They relate to it. I'm going to add just real quickly a user ID, and so that it shows it because it passes the user ID. It might actually, and then the user ID gets passed to the lock. There's an association with scan, creates a scan, and then the scan is passed to the validator. The validator contains the scan information. The scan has the lock, the time, the date, the card number, which is, I would say, is the user number. All right, when it validates, it goes to the data class here and gets the permissions, and the permissions are contained. That's a composition, so it's contained in the data class. It passes the whole scan, including the information here, to the validator, which returns whether or not that it's good. It can also create an alert if it's somebody's scanning something that it shouldn't, and that alert would be an object that would be sent to a user that could see it, like a security person. Not sure I explained that real well, and I might redo that a little if I were to do it again. But that is an example of the classes with the relations. I'm going to show you another one, utterly unrelated to this example. And this is like a card game. So what I have here is, and I notice here that I didn't include all the sets and gets. When you code it, you would have to, but you don't have to in the diagram. So I have a card. Every card has a value. It has a suit. It has a name. And I said that it has an image because you could pull up the image of the card. It has a string function, which would return the name of the card and its value. All right, cards belong to a deck. And I'm saying that the card has an existence outside the deck. But a deck is essentially a list of cards. And the methods here are you can add a card, you can set the deck, and then you can get the deck from here, the deck that's there. I have an abstract class called game. An abstract class is a class that you can't actually ever use. It's just a way to collect things that are common. So this one has, a game has a deck, it has a description, it has a get deck and a set deck. I gave it a shuffle deck. It has a string to say what's going on. I also added a thing for turn, because every game has a turn. Down below this, inheriting from it, I have, and again, deck is contained in abstract game, so it is just a aggregation. This is inheritance. Blackjack is a particular game. It will get all these methods plus all the things that are particular to blackjack, like the rules. When you describe the turn, because up here this is just an empty method. Down here you'll describe what makes a turn in blackjack. And anything that you need to actually do the blackjack game. This could be quite complex, and it could break off into even more classes. Part of any game is a hand, and the hand has a list of cards. So it's a blackjack game, so when it'll deal out cards. And so it'll give a list of cards for the hand. You can add a card, you can remove a card, and then you can get the hand. You can show what the whole hand is. The player has a hand, and I'm saying that the hand belongs to the player, and if the player goes away, so does the hand. That's why it's composition. And a hand the player has a hand, it has a name, it has points, and what game they're playing. I think that. And then they have their set hand and their show hand. And then everything is run through a main. Okay, so that's my card game setup. And again, you can see the relationships. We've got inheritance, we've got composition, we've got association, and we've got, well, composition, yes. So I hope that helps. It may confuse things more. I'm not sure. But I'm done with that. Please, if you have questions, you can put it in the discussion forum or email me. These are a little bit complex, and it would be worth your while to actually think these through, because these are really the key to coding when you get to that. We'll talk about the coding later. So I'm going to stop this recording.